It has come to my attention that we've been lied to about the number of days per year. Now, you might believe, and rightfully so, there are 365 days in a year. There are 365 day night cycles, sun up, sun down. But we also associate days with how many times the Earth rotates. So, one Earth rotation correlates to one looking at the sun. But if we look at our little hypothetical planet here, that's just obviously not the case. That's a rotation, right? We're facing the same direction as when we started. We're not looking at the sun. We're just not. Like straight up, we aren't. So that's not a sun up, sun down. It's not a day night cycle. It just isn't. Right? Nobody on this planet experienced a sun rise. It just didn't happen yet. So somewhere there's a discrepancy between the rotation and the number of days, or at the very least when they occur. Well, let's simplify things a little bit. Let's say that our hypothetical planet, which in this model is bigger than the sun for some reason. I guess I could just make that not the case. I could shrink the planet here, so it's a little more to scale, but we're gonna deal with it. It makes it easier to tell what direction it's facing. What if our planet never did a rotation? What if that just did not happen? What would we experience? Well, halfway through the year, it would be nighttime. Odd. And then, as the year concludes, the sun would rise from the right of our observer. So, despite never doing a rotation, we were facing the same direction this whole time. We had one day. We had one sun up, sun down. So it seems like we get a free day just by virtue of doing the revolution. Revolution is this way. Rotation is this way, about the axis, or is about the sun. So given that we experience 365 sun up, sun downs, I guess we only have to do a rotation 364 times, right? One fewer, because you get a free day. Well, if you look it up, you get a different number. Actually, you have one more. By the way, if you are looking this up, you have to look up sidereal rotations, because Google tries to correct you, I guess, if you do the other one. It just says, yeah. So, okay, we do get a different number. So make sure you're looking up sidereal rotations, because otherwise it'll default to the sun one. Just saying. The keyword here is sidereal. All right. Because sidereal means you're facing the same direction, not the sun. And that's what we're talking about right now. So let's put up our counters, okay? What is going on? Why is it not working out? Well, for one, in our demonstration, let's make it the way the Earth is. The Earth rotates counterclockwise and revolves counterclockwise. Or I guess if you're looking from the other direction, they'd both be clockwise. But the important part is they're the same. So, when we have a day, the sun rises from the left. Sunrise from the left of our observer. I know it's awkward because you have to shift from the left. But what did we get from the year itself? The sun rose from the right. So we're not really getting a free day from the revolution. We're getting a negative day. The sun wants to come up in the opposite direction because of the year. And that's really the difference. If the Earth were to spin the other way, say you give it a lot of what I have negative days here. So now it's spinning clockwise. The sun goes up on the right, which perfectly aligns with the sun going up on the right from the year. So in this case, you count it out, you get one more sun cycle day. Then you have looking at the same direction day. All right, let's count it. One sun, one distant stars facing the same direction. Second sun, second full rotation. Third sun, third full rotation. Four sun, four rotation. Five sun, five rotation. Six sun. See, that was a quick one. And then add for both. Right? But then going the other way, let's make this simply 2 days, so it's easier for me to count. Now we're going counterclockwise like the Earth again. So we just had a full rotation. That's one. And then we look at the sun and the full rotation at the same time, adding one to both. So that's what's happening. And that's why we actually have one more sun cycle day. I keep messing up the phrase. You get one more rotation day than you do sun cycle days. Now, unfortunately, if I set this to a really big number, Desmos just isn't really capable of it looking pretty. Like, look at that. It just freaks out. At the very least, we get the counter to work properly. So we do have to limit ourselves to only a handful of days. But this is a really significant thing. It's not like leap year where you're just off by a little bit because it happens to not line up. And, oh, you can't have a quarter day, so let's just chop off 4 quarters in 1 day every 4 years. But this, also, leap year is not exactly a quarter day, just putting that out there. But this is not just a rounding error. This is a fundamental fact about orbits. You will always be off by 1. Granted, it's a circular orbit, you're, playing fair, you got a sun, you got a planet. I don't know how ellipses work literally at all. Okay, this is just a thing that I realized when I saw someone going around an object, and then I thought you'd get the extra day. And I was telling people, yo, it's 364, man. And then I looked up at 366. And that's when it really hit me. You got to go the other way. The direction matters. The direction matters so much that if you're spinning 1 day, well, 1 minus 1 is 0. And the moon does this. You always see the same direction of the moon. Because the moon spins once every, 29.5 Earth days, and it revolves around the Earth every 29.5 days. It's the same number. So you see the same part of the moon. Because it experiences that number of spinsies days minus 1. It has the same deal. That's what's happening with the moon, because it lines up. You have 1 minus 1. Yeah, so you have 366 rotation days. That's what we found. And now let's just find out how many hours is one of those days. Now we're going to treat it as 365.25. Not going to worry about how it's not exactly that close enough. There are more or less 365.25 sun cycle days per year, and that's 24 hours. Let's make it more readable, actually. There's 365.25. See, this is too bright. There are 365.25 days per year, sun cycle days. They each have 24 hours. And within that same time, the Earth must rotate 366.25 days. Just add 1. So, how long does it take in hours to do one of those rotations? Well, you just say, this is the length of time it takes, and divide by how many there are. So, total number of hours per year, divide by the number of rotation days. And it's this number, which we can verify. Let's go to Wolfram. Sidereal day divided by hours.